All right, in today's review lesson, we're going to review what we learned earlier this year about proportional relationships. So in your table of contents and at the top of your page, write Proportional Relationships Review. That's your title for today, Proportional Relationships Review. Hit pause and set that up. When you're ready to move on, hit play. All right, as in our other lessons, this should already be in your notes. This is just to refresh your memory. You don't have to copy this unless you've lost it or you don't remember it. But remember, first, what is a proportional relationship? It is when two quantities, x and y, have a proportional relationship if y is always a constant multiple of x. So if we do the ratio y divided by x, it should be the same thing every time. So how do I determine if a table shows a proportional relationship? What I just said, we want to find y divided by x. That's going to be our constant of proportionality. It should be the same thing for every row of the table. If that y divided by x is the same for every row of the table, then it's a proportional relationship. So let's look at an example of that. So here we see y divided by x, 2 divided by 1 is 2, 4 divided by 2, it's also 2. 6 divided by 3, also 2. 8 divided by 4, also 2. So is this a proportional relationship? Yes, it is, because for every single row in the table, y divided by x gave us 2. 2 was the constant of proportionality. So check this one on your own. Does this table show a proportional relationship between x and y? Let's do y divided by x for every single row in the table. Row 1, 1 divided by 5. If I type that in the calculator, that gives me 0.2. Row 2, 15 divided by 3. That's 5. Are these going to be the same? No. So is this table showing me a proportional relationship? No, because there's not a constant of proportionality. I could do the next two rows, but I really can stop there. If I see that the first two rows are different, I can stop and say it's not a proportional relationship. All right, next, refresh your memory about proportional relationships in graphs. How do I determine if a graph shows a proportional relationship? There are two requirements. You need to have these memorized. Okay, if you don't remember them, you might want to jot them down. Two things, it has to be a straight line graph that passes through the origin 0, 0. So looking at this example down here, we see from the points that are plotted, if we draw a line through them, is it passing through the origin 0, 0? Yes. Is it a straight line graph? Yes. So is this showing a proportional relationship? Yes, it is. Meets these two requirements. Okay, so looking at each of these graphs, do these show a proportional relationship between x and y? A, what do we think? It is yes. We see 0, 0, the origin, and it is a straight line graph. What about B? No. Why not? Because it doesn't pass through the origin. What about C? No. Why not? It's not a straight line graph. It bends right here. Okay? So it has to be both. It has to pass through the origin and it has to be a straight line. If it doesn't meet both those requirements, it is not showing us a proportional relationship. All right, next, giving a name to that ratio of y divided by x, that is called the constant of proportionality. Y divided by x, when I have that in a table or a graph, I do y divided by x, and that is called the constant of proportionality. It has to be the same thing for every row in the table. So again, here's a different table. If we did y divided by x, 20 divided by 1 is 20, 40 divided by 2 is 20, 60 divided by 3 is 20, 80 divided by 4 is 20, 100 divided by 5 is 20. So is this showing us a proportional relationship? Yes, because we got the same thing every time. And we call this number 20, that y divided by x, is the constant of proportionality. The constant of proportionality is 20 centimeters per brick. And again, just a reminder, if x and y have different units, the constant of proportionality can be written as a unit rate. It's okay if they represent different things on the top and the bottom. All right, hit pause and find the constant of proportionality here. We want to find the constant of proportionality for the number of shoe boxes in one column. We see it's 45 inches, so figure out what would be the constant of proportionality for per shoe box. We would say 45 inches How many shoe boxes are in this one column? 1, 2, 3, 4, 5 shoe boxes. So what would that be if I divided? 9 inches per box. That is B. Okay? Finding the constant of proportionality. Okay, also remember that we call this ratio of y divided by x the constant of proportionality. So a proportional relationship is represented in an equation by this little formula here. You may want to jot this down because it's been a while since we talked about this. This is the formula for a proportional relationship. This is the equation for a proportional relationship. Y equals m times x. Now, it's not the same thing as slope-intercept form, which we discussed a while back, y equals mx plus b. What is the plus b going to be for this? It has to be 0. Guess why it has to be 0? Because with a proportional relationship, it has to pass through the origin 0, 0. That plus b, the y-intercept, can't be anything else other than 0, or it's not a proportional relationship. Okay, so our formula for a proportional relationship is y equals m times x, where m stands for the constant of proportionality, or we learned it as the slope when we did the slope-intercept form. Okay, x is just going to be x, that's the independent variable. Y is just going to be y, the dependent variable, but m is going to be a number that represents the constant of proportionality, or you can even call it the slope. Again, what is the y-intercept going to be? 0, because we don't see plus or minus anything on the end of this equation. So in this equation, y equals 8.5x. We can find the total cost y in dollars for x movie tickets. What is the constant of proportionality shown in the equation? There is no math required in this problem. All I have to do is use my knowledge of the proportional relationship formula, y equals m times x. What's that number that's the constant of proportionality? 8.5. What is the constant of proportionality shown in the equation? 8.5. What does that mean in this situation? We're trying to find the total cost y for x movie tickets. So we're multiplying it times the number of movie tickets to find the total cost. This is going to be the cost per ticket. That's what we multiply times the number of movie tickets to find the total cost. So if we were finding for 13 movie tickets, we would do 8.5 times 13. 8.5 times 13. If I took my calculator and just punched that in, I would get 8.5 times 13 equals $110 and 50 cents. $110.50. Okay? Okay, what about this equation? What is the constant of proportionality here? It should be what? 4, right here. You see the 4? That is our constant of proportionality. What is the perimeter? If we have side lengths of 1.6, we just plug in the side length of 1.6 in for, oops, I went too far, right here, not here, and there for x. So 4 times 1.6, punch in the calculator, 4 times 1.6 gives me 6.4. So the perimeter would be 6.4. Okay. We can also set up and solve proportions. This is kind of a different take on proportional relationships. So we've learned how to tell if a table, a graph, and an equation are proportional. We can also determine if two ratios are proportional. They're equal to each other. So a proportion is an equation stating that two ratios are equal. You can use a proportion to solve a problem. We haven't done this in a while, so let's refresh our memory. You've had this on your spiral reviews. To solve a proportion, we set up the two equivalent ratios. You can either look at the relationship going straight across and figure out what to multiply by, or you can cross multiply and then divide by the number with the variable. So here, if we were going to do that, we would cross multiply, meaning diagonally across. 5 times W is 5W. 3 times 188 is 564. That's what I did here. Then I just have a one-step equation to solve. So I divide by 5, divide by 5. 564 divided by 5 gives me 112.8. Okay, so solving a proportion, setting it up and solving, I cross multiply, and then I divide. Last thing is an application of a proportion, and you need to remember how to set up the proportion using the scale and the scale drawing. Remember, we call a scale drawing an enlarged or reduced drawing of an object that is proportional to the actual object, and the scale is the ratio. We use that on the left side of our proportion. It compares a length in a scale drawing to the corresponding length in the actual object. So if we had a scale here, 1 inch on the scale drawing represents 15 feet on the actual sailboat, then we would set up a proportion using those measurements. So let's practice that. So here we have a billboard. They gave us the scale is 1 inch equals 1.5 feet. They want us to convert the dimensions of the billboard. So I'm going to have to do 2 separate proportions. I'm going to start over here with the length of the billboard. So you always start by making the scale the left side of your proportion, 1 inch over 1.5 feet. And you may even want to write the units out to the side to help you with setting up the other side. So the scale goes on the left of your proportion, and then we're going to take the measurement from the actual object and plug it into the proportion on the right side. So 8 inches, that is going to go where? Top or bottom on the other side of my proportion? On the top, I've got my inches on the top. So then N is going to represent the measurement from the actual billboard. So then I just cross multiply. 1 times N is 1N, and then 1.5 times 8 is 12. So I don't have to divide since I just have 1N, which is N. This is going to be 12 feet. Now if I have to convert the second measurement as well, which they asked me to do, I would do a second proportion. But I would not change the left side, that's the scale. The scale stays the same for both of my measurements. So 1 inch still represents 1.5 feet. This time I'm converting 16 inches. I want to know what that would be on the actual billboard. So again, I cross multiply. 1 times N is 1N. And then 1.5 times 16 is 24. So I would get 24 feet here. They might even ask you to, yeah they do, ask you to find the area of the actual billboard. So remember, area is just length times width. So 12 times 24 to get the area would be 288 square feet. Okay, so again, setting up and solving the proportion, you use the scale on the left side of your proportion, then you take the measurements and fill in whatever the one that's missing with the variable, and you put that on the right. All right, at this point, you should be ready to work on your digits. Let me know if you need help.